Alright, let's take a look at number 2 on the practice exam. Okay, so very simple statement and a little picture here. It says, what's the area of the shaded region in the figure below? Okay, so you can see this blue stuff here is shaded. Alright, and so how are we going to figure this out? So there are two areas involved and we can compute both of them. Okay, so there's the area of this circular sector. Alright, so that's one thing. There's also a triangle in this picture, right? So we have the area of the circular sector, which I just drew in red, and then we have the area of the triangle, which I'm drawing right now in magenta. And okay, so what is the answer going to be? The answer, the area of the blue shaded region is going to be the area of the red region minus the area of the magenta region. Okay, so I really hope nobody is magenta colorblind or can't tell the difference between any two of these three colors. Alright, so let's just figure these things out one at a time. So I think the circular sector is the easy one. Okay, so there's a formula for this, but in case, I'll give you the formula in the exam, but to be honest with you, I haven't memorized the formula because I always figure things out like this. Okay, so look, this circle has radius 3. Alright, so the total area of the circle is pi r squared. So pi times 9 is the area of the whole circle. And okay, so the area of the sector is going to be a certain fraction of the whole area of the circle. And it's going to be the same fraction as how much 100 degrees eats up out of 360 degrees. Okay, so hopefully you believe that. So this gives me an easy way to solve for A. Alright, so A is just 9 pi times 100 over 360. And so this is not going to be a nice number. Let me check my sheet of paper here where I figured this out. So this turns out to be 7.85398, and okay, so how much of it do we really need to know? That's probably more than enough. Alright, so now let's focus on finding the area of the magenta triangle. Okay, so we need to take that away from the area of the sector that we just found. So let's just redraw this triangle on its own. So it has some sides. Okay. So this angle is 100, and I know some things about this triangle because look, this is also the radius of the circle, right? This side is also the radius. So that means that this is an isosceles triangle. Okay, and this actually, since these two sides are the same, it means these two angles have to be the same. And since everything has to add up to 180, these two angles have to be 40 degrees. Okay, so actually we don't even need to know what those things are because we have this formula. I'm going to, in class, show you this formula probably. Maybe I should be using magenta, right? I'm going to show you this formula in class sometime. So one way to figure out the area of a triangle is to do 1/2 AB times sine theta, okay? And so this applies in situations where you have a side of length A and then a side of length B and then an angle theta in between. So that's where this formula comes from, and we'll prove the formula in class, or you can look it up in the book. But let's use it in this situation, okay? So in this situation I've got 3 and 3 and the angle 100 in between. So the area of the triangle is going to be 100 times 3 times 3, which is 9, times sine of 100, and that all comes out to be 4.43165, let's say. Okay, and so now the answer to the question is the area of the sector take away the area of the triangle. So 7.85398 minus 4.43165, and You can figure this out on your own. I'm looking to see if I did it somewhere on this sheet of paper. So just put that into your calculator. Okay, problem done.